All right, in this first video, we're going to solve a quadratic equation using square roots. Now, in our last lesson, we solved quadratic equations by factoring. We put it into factored form, set our factors equal to 0. So this lesson is going to have us just learn another method of solving using square roots. So our first equation, we have x squared equals 16. So it's an x squared, making this a quadratic equation. What we want to notice is that x squared and 16 are both perfect squares. So what you can think about is, what can I square to get 16 as an answer? So you might say, oh, 4. Yeah, 4 squared is equal to 16. So 16 equals 16, check. That means that x equals a 4. But what we want to remember is that we can square negative numbers and that will result in a positive answer. So are there any negative numbers we could square and get 16 as an answer? And as we explore negative numbers, we'll come up with negative 4 squared as a possible, or as another solution. So is negative 4 squared equal to 16? Negative 4 squared is 16, which equals the 16. So check, we also have x equal to a negative 4. We can write that more efficiently. We can say x is equal to a positive and a negative 4. Plus or minus 4 is how we say that. Another way to approach that, if you have x squared equals 16, and we solve equations often by undoing or doing the opposite operations. So what's the opposite of squaring? We can undo the squaring by taking the square root of both sides. The square root of x squared is x. The square root of 16 is 4. When we solve using square roots, what we have to remember is all of this right here, that there are two possible answers. There's the positive 4 and the negative 4 that we could square, and that will result in that positive 16. So on our own, we do have to remember to include the plus or minus to get that x equals plus or minus 4. All right, part B, x squared equals negative 9. So what number can we square that will result in a negative 9? And as we think through possibilities, there is no number you can square and get a negative answer. A positive times a positive is positive. A negative times a negative will be positive. So there's no real number that we can square that will result in a negative 9. So we have some creative mathematicians that found a way to work around this. And so we're pretty thankful that they said, we can continue to simplify this just using our properties of radicals. So if we have x squared equals negative 9, let's square root both sides like we did with that last problem. Square root of x squared is x, and now we're dealing with that square root of negative 9. We will have a positive or negative square root of negative 9. Now, you can't square root a negative number, so let's break this up so that we can get a number that we can square root. So plus or minus, I'm going to break this up into square root of 9 times square root of negative 1. We can, using properties of radicals, we can find factors of negative 9 and separate it into two separate square roots. The square root of 9 times the square root of negative 1 is the same as the square root of negative 9. And what that allows us to do is take the square root of 9, which is 3, times the square root of negative 1. Now, this square root of negative 1 has a definition. The mathematicians then were saying, we're going to call that I. We're going to let I equal the square root of negative 1. Because anytime we're trying to square root a negative number, we can break it apart like this. Square root the positive times the square root of the negative 1. And then how can we define the square root of negative 1? We're going to call that I. And then that allows us to say that, I'm still solving this equation, so x equals plus or minus 3 times, instead of square root of negative 1, 3 times I. All right, so what is this I? What's this all about? So this is an imaginary number, I, We've maybe referenced this in earlier math classes. Oh, wait till you get to Algebra 2, you're going to learn about imaginary numbers. Every time we've talked about numbers up to this point, we've always said all real numbers, real numbers, real numbers, real numbers. Now you know that there are things outside of real numbers in the world of mathematics. So we always had to be specific that we were focusing on real numbers because we had to make sure we weren't including all of these the imaginary number I and these complex numbers. So I'm going to write in the definition of complex numbers first, and then I'll fill in the definition of imaginary number. So a complex number complex numbers are numbers that can be written in the form that doesn't look like an A plus BI, where A and B are real numbers and I is the square root of -1. So the imaginary number is any number BI, where B is a non-zero real number, and I is the square root of -1. So just some examples of complex numbers so we just understand what they look like. Let's see, -6 plus 4i. That's a complex number. Our A is equal to -6. Our B is equal to 4. Those are the real numbers. And then I is the imaginary part right there. Another example, 7 minus I times the square root of 2. So if you have a radical, the I will go in front just because the radical will go on the end. Where in this example, our A is a 7, the B is a negative square root of 2. Because the B is the number with the I, but because of a minus, it would end up being negative. So these are just examples of complex numbers. They have real parts and imaginary parts. I is equal to the square root of -1. We're going to use this a lot in helping us solve these quadratics.